log analysis assignment using Python. This dataset contains HTTP server logs where each line represents a request, including host, timestamp, request details, response status, and bytes transferred. Instead of manually uploading a large file, I used a direct FTP download. This ensures reproducibility and avoids manual dependency, which is important in production workflows. This dataset is compressed, so I extracted it using gzip to convert it into a readable log file. This is the core of the pipeline. Since the data is semi-structured, I use regular expressions to reliably extract fields like host, timestamp, request, status code, and bytes. Regex is used instead of simple split because log formats can vary, and regex gives controlled extraction. I explicitly handled missing values here, converting it into none, so it doesn't break numerical analysis later. From the request string, I extracted the file name. I also added error handling in case the request is malformed. Here, I iterate to the entire dataset and convert raw text into structured dictionaries. This transforms unstructured logs into analyzable code. This approach loads data into memory, which is fine for this dataset size, but for larger datasets, I would switch to streaming or chunk-based processing. For basic metrics, I used length for total records and set to efficiently compute unique hosts. Here, I convert timestamps into date time objects to enable grouping by date. Then I use sets to ensure unique file names per day. I filter 404 responses and use dictionary based counting to identify frequently missing resources. This is useful in real systems to detect broken links or missing assets. While extracting the file extensions, I observed noisy and inconsistent values. So instead of blindly counting, I filtered only valid extensions. This step improves data quality and prevents misleading insights, which is critical when working with real world logs. Here, I apply time based filtering and aggregation bandwidth using dictionary summation, skipping invalid byte values. I initialized all 24 hours to ensure completeness, even if some hours have no traffic. This uses frequency counting and sorting to identify the most requested resources. This provides a distribution of HTTP response, which helps understand system health. I focused on handling messy data rather than assuming clean output, applied filtering and normalization to avoid misleading analysis. For larger datasets, I would move to streaming or distributed processing.